Welcome. I'm so excited to have you here again. Let's take a look at the JAMB question 6, JAMB Physics 2020, which says hot water is added to 3 times its mass of water at 10 degrees Celsius and the resultant temperature is 20 degrees Celsius. What is the initial temperature of the hot water? Fine. We are looking at the principle of mixtures here, which states that the heat lost by a hot body is equal to the heat gained by the cold body when they are mixed together and attain the same temperature. So what we're talking about is this heat energy given by hot water is equal to the heat energy taken by cold water. I hope it is not clearly stated, but given that the temperature of the water is 10 degrees means that obviously this is a cold water. All right, so another interesting part is, let's write out the formula first. We're talking of the mass of the water times specific heat times the change in temperature equal to the mass of the cold water times specific heat times the changes or the difference in temperature. Remember that we're told that the mass of the cold water is 3 times that of the hot water. Don't forget that. All right, so the hot water on the other side is the one that lost heat. Okay, so for the heat loss, talk about the changes in the temperature. Okay, so the initial temperature we don't know, let that be T, so we subtract the resultant temperature, which is 20 degrees, from the initial temperature. So this is the changes in the temperature of the hot water. So we're going to write this out: M times C times T minus 20 degrees Celsius. All right, good. And on the other hand, the heat energy taken by the cold water, what happened are the changes in temperature. What really happened? Okay, let's check that out. So the cold water gained heat energy. It gained heat. All right, heat was gained. So what would be the changes in the temperature? We're looking at 20 degrees minus 10 degrees, because the initial temperature was 10 degrees, then the resultant temperature is 20 degrees, which means it has gained heat. So 20 degrees minus 10 degrees Celsius, we have 10 degrees Celsius. Okay, so that is what we'll write down here. All right, so we're trying to get the value for the T. The mass and the specific heat will cancel out on both sides of the equation. All right, then we are left with the initial temperature T minus 20 degrees Celsius equals 3 times 10 degrees Celsius. We have 30 degrees Celsius. So finally we're going to have the initial temperature equal to 30 degrees Celsius plus 20 degrees Celsius, and that gives us 50 degrees Celsius. So that is the temperature of the hot water before it was mixed together with the cold water. That is the initial temperature of the hot water. So answer option C is the right answer. Thank you for watching, and do make sure you like this video, leave a comment in the comment section. Bye for now.